Diamonds truly are one of Mother Earth's simplest yet most complex forms of natural beauty, comprised of just one element, carbon. Diamonds are considered to be the hardest substance on Earth.
We've all seen diamonds on rings, on red carpets, and rap videos, but how are they really made? Not just the romance and sparkle, but the raw, gritty process that turns carbon into one of Earth's hardest, most valuable stones. Some are born deep underground over millions of years. Others are grown in labs using fire and science. From ancient volcanoes to industrial drills, from dusty mines to high-tech chambers. This is the full journey. No fluff, just the facts. Welcome to the real story behind diamonds. It's rough, it's brilliant, and it's nothing like you imagined. A brief history of diamonds. More than 2,000 years ago, deep in the riverbeds of India, something caught people's eyes. Small, glittering stones that were unlike anything they had ever seen. These were diamonds. And back then, they weren't worn on fingers or displayed in jewelry stores. They were believed to hold power, spiritual shields that could protect against evil and bring good luck. In early Asian cultures, diamonds were treated almost like sacred objects. Fast forward to 1947, and the meaning of diamonds took a sharp turn. That's when the famous slogan came out, "A diamond is forever." It was part of a campaign by De Beers, a diamond company that changed how the world saw these stones. Suddenly, diamonds weren't just rare. They were romantic. The diamond engagement ring became a symbol of lasting love. It was no longer just a shiny rock. It was a promise. Since then, diamonds have kept evolving in meaning. Today, they show up in everything from red carpet fashion to hip-hop music videos. They're not just about love anymore, they're about success, confidence, and status. Whether it's a rapper flashing a grill or a couple getting engaged, diamonds are everywhere. But behind all the sparkle, there's still something magical about them. Because even with all the marketing and modern use, they remain one of Earth's most mysterious and fascinating creations. As one gemologist put it, a diamond is the story of pressure, time, and patience. And that story is just getting started. Let's move from legend to science and see how nature actually makes these gems.
They are the purest form of transparent carbon, and they form under tremendous pressure and depth, typically about 150 kilometers below the Earth's surface. They are then transported to the surface of the Earth in volcanoes, and they're very special volcanoes that we refer to as kimberlites.
Deep Earth origins, natural diamond formation. Every diamond on Earth started the same way, with carbon. Yes, the same carbon found in pencil lead. But instead of staying soft and dusty, this carbon went through a serious transformation. Roughly 100 miles beneath the Earth's surface, it gets really intense. Temperatures hit over 2,000 degrees Fahrenheit, and pressure builds up to hundreds of thousands of pounds per square inch. Under these extreme conditions, carbon atoms lock together in a special structure called a crystalline lattice. It's tight, it's strong, and it's what gives a diamond its famous hardness. This whole process doesn't happen overnight. It takes millions, sometimes billions, of years. Deep in the Earth's mantle, carbon slowly turns into diamond, and sometimes extra elements sneak in during the process. Nitrogen can give a diamond a yellow tint. Boron might turn it blue. Even rare pinks and greens are caused by small tweaks in their structure. These so-called impurities actually make each diamond unique. As one geologist said, every diamond is a fingerprint of the Earth's history. Now that we know how diamonds are formed deep underground, how do they actually reach the surface? Time to head from the Earth's core to the surface, where ancient volcanoes come into play. From mantle to market, how diamonds reach the surface. So how do diamonds formed 100 miles down end up in your ring or necklace? The answer lies in something dramatic. Volcanoes. But not the ones we see bubbling with lava today. These were ancient eruptions. Deep, explosive, and long extinct. Millions of years ago, these eruptions blasted through the Earth's crust, carrying diamonds up with them. The path they left behind is called a kimberlite pipe, a vertical tunnel of volcanic rock. Kimberlite pipes are rare, and not all of them have diamonds, but when they do, they're like nature's elevator, transporting diamonds from the depths to where we can find them. In fact, the name kimberlite comes from Kimberley, South Africa, where one of the first big diamond discoveries was made in the late 1800s. Here's a fun fact. The last kimberlite eruption happened around 30 million years ago. That means every natural diamond on Earth is older than the human species. In places like Siberia, Canada, and Botswana, massive open-pit mines now surround these old volcanic paths. Some go as deep as half a mile. They're so big they can be seen from space, but digging them out isn't easy. As one miner in Russia's Mir mine said, "You don't just find diamonds, you earn them." So far, we've followed diamonds from their ancient beginnings to their explosive journey to the surface. Next, we'll see how humans dig them out and what it takes to turn a rough stone into something truly brilliant. The mining front lines. Digging for diamonds. Now that diamonds have reached the Earth's surface, the real work begins. Getting them out. And make no mistake, this is heavy-duty labor. The most common method is open-pit mining, where enormous holes are dug into the ground to reach diamond-bearing rock.
Diamonds are incredibly rare and they're very difficult to find. And it can take decades to actually make a discovery that will go on to become a commercially producing diamond mine. So the process is very involved. We as geologists spend a great deal of time identifying areas to go and explore. And then if we are lucky enough to make a discovery from drilling, it then is a whole.
At places like the Mir mine in Siberia or the Jwaneng mine in Botswana, the scale is mind-blowing. Trucks the size of houses crawl in and out of massive craters all day long. The deeper they go, the more rock they haul. When the diamonds lie deeper, underground mining takes over. This involves carving tunnels deep into the earth, sometimes over 3,000 feet down. It's dark, dangerous, and full of strict safety rules. One miner joked, "We don't dig for treasure. We dig through a puzzle every day." Then there's alluvial mining. This method is simpler and often done in riverbeds or along coasts. Loose gravel and sand are sifted through using machines or pans, kind of like gold panning. The idea is to catch diamonds that were carried away by water over millions of years. All of these methods are aimed at one goal: finding enough rock that actually contains diamonds. And even that's tricky. On average, miners process 1 ton of ore just to get about 1 gram of diamonds. So the odds aren't great, but the reward can be huge. Once collected, all that rock heads to a processing plant, and that's where the science kicks in. Ore to gem, how diamonds are processed. At the processing plant, raw rock becomes refined treasure. The first step? Crushing. Big chunks of kimberlite are broken down into smaller and smaller pieces. Think of it like making gravel, but with million-dollar potential. Once it's small enough, it goes through something called dense media separation, DMS. Here's how it works. The crushed rock is mixed into a liquid made of ferrosilicon and water. Diamonds are denser than most of the rock, so they sink, while everything else floats. Simple, but smart. Then comes the high-tech part, X-ray sorting. Each stone passes under a beam of X-rays. Diamonds reflect light in a unique way because of their crystal structure. The machine spots them, and a quick blast of air pushes them onto a separate path. As one technician explained, it's like finding a needle in a haystack, with a robot that knows exactly what a needle looks like. Finally, the diamonds are cleaned in a chemical bath to remove any leftover rock or dirt. At this point, they're still rough stones, unshaped, unpolished, and pretty underwhelming to look at. But this is where the magic begins. Because next we step into the world of labs, where humans don't just find diamonds, they grow them. Lab-grown legends, creating synthetic diamonds. Why wait millions of years when you can grow a diamond in weeks? That's the thinking behind lab-grown diamonds, which are becoming more popular by the day. The first real success came in the 1950s. But back then, the diamonds were only good for industrial tools. It wasn't until the 1970s that scientists managed to create diamonds clear enough for jewelry. There are 2 main methods: high pressure, high temperature, and chemical vapor deposition, CVD. In HPHT, a tiny diamond seed is placed in a capsule with carbon, usually in the form of graphite. Then it's heated to around 2,500 degrees Fahrenheit and pressurized to around 870,000 pounds per square inch. Basically, they recreate what happens underground, just way faster. Over days or weeks, the carbon forms a new diamond around the seed. In CVD, the process is more high-tech. Gases like methane and hydrogen are released into a chamber at low pressure. Then the gas is ionized using microwaves or lasers. Carbon atoms break free and slowly settle onto a flat diamond seed, growing layer by layer. Scientists love this method because it allows more control over the diamond's shape, color, and clarity. As one lab engineer put it, We're not just copying nature, we're improving on it. And they're not wrong. Lab diamonds are nearly flawless, easier on the planet, and much cheaper than mined ones. For many buyers, they're the smarter choice. Next, we'll find out how both lab and natural diamonds are cut, polished, and turned into the sparkling stones we see in stores. Cut to shine, shaping the diamond. Once a rough diamond is ready, it's time to unlock its true sparkle. This next phase is all about cutting and polishing, and it's where raw becomes radiant. Every diamond is unique, so it starts with a close inspection. Experts, known as planners, study the stone under magnification to figure out how to cut it with the least waste and the most shine. As one planner says, a good cut doesn't just shape a diamond, it brings it to life. The first major tool is the cleaving saw or laser, used to split the stone into smaller pieces. After that, brooding machines give the diamond its round shape, like sketching the outline before coloring it in. Then comes the detailed work, faceting. Facets are tiny, flat surfaces that reflect light. When cut at the right angles, they create that iconic sparkle. This is called brilliance, and it's what most people fall in love with when they see a diamond shine. To do this, cutters use spinning wheels coated in diamond dust. Yes, only diamonds are hard enough to cut other diamonds. Finally, polishing smooths out every facet to a mirror finish. It's slow, careful work. Even a small mistake can affect how the diamond catches light. By the end, a once cloudy rock now flashes with light. It's not just a gem anymore, it's a masterpiece. With our sparkling stone complete, it's ready for judgment. Time to meet the 4 C's, the global standard for grading diamonds. The 4 C's, how diamonds are graded. When it comes to diamonds, beauty might be in the eye of the beholder, but value is measured by the 4 C's: cut, color, clarity, and carat. Cut is all about craftsmanship. A diamond with perfect proportions will reflect light better and look more brilliant. This doesn't mean shape, it means precision. As graders say, a poor cut can dull even the most flawless stone. Color actually refers to the absence of it. Diamonds are graded on a scale from D, colorless, to Z, light yellow or brown. The closer to D, the rarer and more valuable the stone. Clarity checks for flaws, both inside, inclusions, and outside, blemishes. Fewer flaws mean higher value. Most people can't see the difference, but under 10x magnification, graders look closely. The rarest diamonds? Flawless with no visible marks. Carat measures weight, not size. 1 carat equals 0.2 grams. Larger diamonds are harder to find, so they jump in price quickly. Grading is done by independent labs like the Gemological Institute of America, GIA. Each certified diamond gets a unique report, almost like a passport, detailing its traits. So now we know how diamonds are judged. But what happens when they're not made for rings at all? Let's look at how diamonds play a huge role outside the world of jewelry. Beyond bling, diamonds in industry and innovation. While diamonds are famous for adorning rings and necklaces, many of them never see a jewelry store. That's because they're just as valuable in industry as they are in fashion. The same property that makes a diamond shine, its hardness, also makes it a powerful cutting and drilling tool. In fact, diamonds are the hardest natural material on Earth. That means they can slice through just about anything. You'll find industrial diamonds in drill bits, saw blades, surgical tools, and even semiconductor tech. And guess what? Most of these are lab-grown. They're cheaper, consistent, and don't need to be flawless to get the job done. As one factory operator said, "You can't build a tunnel or cut titanium with rubies, but diamonds get the job done." These functional diamonds help build roads, cut metal, and even assist in space exploration. And they're not going away anytime soon. Back in the world of jewelry, the debate between lab and natural diamonds continues. One offers tradition and rarity, the other offers ethics and affordability. Both shine in their own ways. At the end of the day, whether it's deep underground or grown in a lab, rough and gritty or cut to perfection, a diamond is always a story worth telling.